Good morning, students. Today's third chapter, rotation and revolution. Rotation and revolution are two important movements of the earth. They go side by side. Earth rotates and moves around the sun on its orbit. Orbit means path. The shape of the orbit is an elliptical shape. Rotation. It is the spinning of the earth on its axis from west to east direction. It takes 24 hours to complete one rotation. That is, time period is known as day. Circle of illumination. It is an imaginary line which shows clear demarcation between the phenomena of day and night. Now you can see this is the line which is dividing the day and night. So this line is known as circle of illumination. Now what's the circle of illumination? You can see the lighted part and dark part. Lighted part is the daytime, dark part is the night. So this is a line, this line is known as circle of illumination. Period of rotation. It is also known as sidereal day. It means that the earth take a 360 degrees of a turn in 23 hours, 56 minutes, 4.09 seconds. So this time period is known as sidereal day. Now you can watch this. Rotation is the spinning of the earth on its axis. The axis is an imaginary line which passes through the center of the earth from North Pole to South Pole. The earth completes one rotation with a span of 23 hours, 56 minutes, 4.09 seconds. Roughly, it is 24 hours. Earth is spinning on its axis. When it is spinning on its axis, the axis is not at right angle, but it is inclined. It is inclined at an angle of 23.5 degrees from the vertical, or you can say it is an angle of 66.5 degrees to the plane of ecliptic. When it is inclined, its axis is always pointing towards the pole star. Annual motion. When the earth is revolving around the sun, it is always inclined. So you can see the elliptical orbit of the earth. Orbit means the path on which different planets moves around the sun. So the plane of the earth's orbit is called elliptic plane. Now here you can see that this is North Pole and South Pole. So this is the axis of the earth. And when we draw the vertical angle, it forms a 23.5 degree. And when we form the angle from the plane of elliptic, this is the plane of elliptic, then it forms an angle of 66.5 degree. So in this way, it is always inclined. So this process is known as inclination of the earth's axis. Now 23.5 degree at the axis, that is a vertical angle, and if we form a line of a axis from the plane of elliptic, then it forms a 66.5 angle. Effects of the speed of rotation. When the speed of the rotation is 16,060 km per hour. So according to that, its effect can be seen on the earth. So first effect is deflection in the direction of wind and water. Water means ocean current. What is wind? Wind is actually a composition of gases. So when this gases strikes with earth or earth strikes with gases, there is a movement, and its movement is known as wind. And because of this movement, when the deflection takes place, it divides into two parts. One towards the northern hemisphere and second to the southern hemisphere, that is to the right hand side and left hand side. Cyclones are formed. Cyclones are the low pressure system with the winds blowing from the surrounding high pressure area to inside. So it is clockwise direction in the southern hemisphere and anti-clockwise direction in the northern hemisphere because of deflection. Pressure belt. When the wind moves, it rises high and then sinks back. So because of that, pressure belt is formed. Movement of air. Movement of air means when air start moving, it is known as wind, and it is because of the rotation of the earth. Effects of rotation. First, it causes day and night. The portion which get light, you can see here in the picture, yellow color, is bright, that's the day, and the other is night. So as the rotation goes on, different part of the area comes in front of the sun and receives sunlight. So day and night is regular feature. The variation in temperature. In the previous chapter, we had learned longitude. There is a 4 minute difference between the two longitudes. So as the earth rotates, after every 4 minutes, longitude comes in front of the sun and that longitudinal area receives the direct sun rays. So because of that, there is a proper distribution of temperature on the earth. The apparent movement of celestial bodies. As just take example, if you are going in a bus or a train, you find that the things opposite to it means outside is moving, like the trees, houses, poles, they are moving to the opposite side. So what is moving? It's train or bus is moving, not trees or houses. In the same way, when the earth rotates, we find that the sun is moving, but it's not sun, but it is a earth which moves. Centrifugal force. As the earth rotates, it creates a force which is known as centrifugal force. Coriolis force. Coriolis force is introduced by Gustav Coriolis in 1835. According to him, when the earth rotates, it's called deflection of the wind and ocean current from the normal path to the right of their course in the northern hemisphere and to the left of their course in the southern hemisphere. So this is known as deflection and it is because of Coriolis force. Centrifugal force. As the earth rotates, it causes a force, and because of this, North Pole and South Pole get flattened and equator get bulges. And the first chapter we had done the shape of the earth. Shape of the earth is joint. So because of the centrifugal force only, earth got its shape, that is a centrifugal, that is a joint shape. Just now watch that the earth is always tilted towards the pole star and its speed is at equator is 1660 km per hour because of its bulge shape, but towards the North Pole and South Pole the speed decreases because of joint shape. Thank you. I think the chapter up to rotation is clear. If you have any question, you can ask.